Welcome everyone. In this video we'll look at an A-level chemistry exam question. Details are in the description. The question covers the ideal gas equation as well as balancing chemical equations and calculating the concentration of a solution. Let's get started. When 250 milligrams of sodium were added to 500 centimeters cubed of water at 25 degrees Celsius, a gas was produced. Give an equation for the reaction that occurs. Calculate the volume in centimeters cubed of the gas formed at 101 kilopascals. The gas constant R is equal to 8.31 joules per Kelvin per mole. First, let's get the balanced equation. Sodium will react with water to produce sodium hydroxide and hydrogen. Knowledge of the diatomic elements and the charge on ions will enable you to work out the formula for the reactants and products. Next, we have to balance the equation. 2 moles of sodium will react with 2 moles of water to give 2 moles of sodium hydroxide and 1 mole of hydrogen. We can work out the amount of sodium that reacts using number of moles is equal to mass over molar mass. The mass of sodium is given in the question. To convert from milligrams to grams, divide by 1000. The molar mass of sodium can be found on the datasheet. The amount of sodium works out to be 0.010870 moles. I will use 5 significant figures for in-process results to avoid a rounding error in the final answer. From the balanced equation we can see that 2 moles of sodium will produce 1 mole of hydrogen. This is a 2-to-1 reaction. To find the amount of hydrogen produced, divide the amount of sodium by 2. This works out to be 0.0054348 moles. The ideal gas equation is PV equals nRT. P is pressure in pascals, V is volume in meters cubed, N is amount in moles, R is the ideal gas constant in joules per Kelvin per mole, and T is temperature in Kelvin. You have to know the correct units for each of these variables and how to convert between units. The pressure is 101,000 pascals. We need to work out volume. We calculated the amount of hydrogen gas produced earlier, 0.010870 moles. The gas constant is given in the question, 8.31 joules per Kelvin per mole. To convert temperature from degrees Celsius to Kelvin, add 273. The temperature is 298 Kelvin. Rearrange the ideal gas equation to make volume the subject. V is equal to nRT over P. Substitute the values into the expression to find V. The answer works out to be 1.33 times 10 to the minus 4 meters cubed. We need to convert this to centimeters cubed. To convert meters cubed to centimeters cubed, multiply by 1 times 10 to the power of 6. The answer works out to be 133 centimeters cubed. Here's the next part of the question. Calculate the concentration in moles per decimeter cubed of sodium ions in the solution produced in the reaction. We constructed the chemical equation and worked out the amount of sodium earlier. We can see from the balanced equation that 1 mole of sodium gives 1 mole of sodium ions. The volume of the solution formed is 500 centimeters cubed. Convert centimeters cubed to decimeters cubed by dividing by 1000. Concentration is equal to amount divided by volume. This works out to be 0.0217 mole per decimeter cubed. Thanks for watching. Post in the comments if you have any questions or suggestions. Take care and good luck with your studies.